section 8.1, then we have 8.2, then we have 8.3, then we have 8.4. So back on track. All right. Now, again, I like the way we're starting because we're starting pretty easy. All right, we're starting pretty easy. Also, I know you're disappointed about the exams. All right, very disappointed. All right, so at some point, I can, if I have enough time today, I can let you see your grade. All right, your semester grade actually. All right, and unfortunately, we're not retaking the exam, or we're not taking the exam. So sorry about that. I know you're disappointed.
Can we do this again?
Yeah. So let's plan for a flood at the end of May, and maybe we can get out of both exams. All right. But for today, we're heading our paper. We're on paper today. All right. And I know all of you got lots of paper for Santa Claus, so no excuses.
I don't have any paper, and
Okay. Again, listen, please. I want to get started. Let's go.
Thank you.
8-1. And it's page 468.
are you though?
1 through 18, 20 through 43.
Oh my God, what are you trying to do? My binder doesn't like me.
All right, so at the end of the semester, we talked about a monomial. And what is a monomial? All right, and we decided that a monomial, or I just meant a single term. I also told you there was something called a binomial, which just means there are two terms. Trinomial, which means there are three terms. And generally after you talk about three terms, you just talk about it as a polynomial, which just means many terms. All right, now, do you remember what separates terms? What was it?
An addition.
Yes, addition or subtraction separates terms. So number one, that is called a what? Generally, number one would be called a trinomial because there are three terms. All right, 1, 2, 3 separate terms. All right. Now it is a polynomial because all of the variables, all right, are raised to a power. This is a to the first power, b to the first power, b to the second power, a to the third power. All of the powers must be whole numbers. All right, you can't have something to the 1.5, or you can't have something to the negative third power. All right, is everybody with me on that? So number one, we can label that as a trinomial. All right. Now, after you label it as a trinomial, we're also going to talk about the degree. Now, the degree is important later on. All right, so we're not going to have too many questions dealing with degree because the degree is pretty simple. All right. If I was just looking at the 7AB, we would say the degree is 2. Why is the degree 2? Because it's the sum of the exponents. All right. So a to the first, b to the first would make this degree of 7AB 2. What's the degree of the second term? 2. What's the degree of the third term? 3. So the degree is always the largest of the terms. All right, so in this case, the degree for number one would be what? 3. All right, pretty easy, correct? So if I look at number 3 now, that's considered a what?
Monomial.
Monomial in what degree?
2.
That's very easy. I told you. If I'm looking at 5, that's a what? binomial, and the degree is what?
That's 3.
The degree is what? 5. Is everybody okay with that? Now remember, now is the time to speak up. We're at the beginning of the chapter. All right, if you get behind now, you would be behind on everything else.
Going back to number 1, for A and B, would it be 2 or is it just 1? And then, like, is it 1 and then they both add up?
The degree for
Yeah.
7AB is 2.
Okay.
Okay? Now let's go over and check 2, 4, and 6. Let's see if you understand what I'm saying. All right, for question number 2, that is considered a what? Trinomial. And the degree is what?
2.
2. That is correct. Anybody have any issues? Look at number 4. Is that a monomial?
No.
No. All right, it's nothing. All right, we don't classify it as a polynomial because there's a variable in the denominator. What about number 6? What about number 6? Somebody said binomial, but you have to look at the powers. It is not classified as a polynomial. It's not classified as a polynomial because of the what? -4. All right, everybody take a look at that now. So 4 and 6 are not considered polynomials. 4 and 6 are not considered polynomials.
So if it has a negative sign in the exponents, would
Then
that
it's not a polynomial. Or if it has a decimal, or if it has a fraction. All right, we say it has to be a whole number. And whole numbers are just the counting numbers plus 0. So 0, 1, 2, 3, any of that. All right, so is everybody comfortable with 1 through 6? All right, I agree. That's pretty easy. All right. Now let's talk about standard form and how simple standard form is. Standard form is just simply writing the variables in descending order. From the largest exponent to the what? Smallest exponent. That's how simple this next section is. All right, so let's look at question number 7. So if I were to write that in standard form, we would just rewrite it as 2x to the 5th plus 3x minus 12. Everybody agree with that? That's very simple. Very simple. You're just rearranging the order. Largest exponent all the way down to the smallest exponent. And the last thing you add on is the constant. All right? So if we look at question number 8. Someone tell me. Go ahead.
So 1, no wait, yeah, so -4d to the 4th.
Very good. Then what?
D to the negative d to the 2nd. And plus 1.
Yep. There we go. Did everybody go with that? All right, let's look at number 9. Somebody else. Go ahead.
-5z to the 4th. -2z to the 2nd. And then 4z to the 4th.
Everybody agree? Very simple. Very, very simple. All right, let's check out number 10. Somebody else. Go ahead.
4a to the 3rd, -5a to the 2nd, 2a
What kind of 2a?
to the 1st.
Yeah, but plus or minus.
Oh yeah, plus,
There you go. And then,
and then -1.
beautiful. Does everybody agree? Does everybody see what I'm saying? It's very simple. Very simple. All right, very important. All right, now, next thing we're going to do is we're just going to do what? Find the sum or the difference, which just basically means we're going to what?
Add or subtract.
We're going to add or subtract. All right. Now, what I want to do is, whenever there's addition, here's the way I want you to think about it. Look up. Is it necessary for that parentheses? No, because we're not multiplying by anything. Same thing here. There's no reason for those parentheses. Everybody see that? All you're doing is combining like terms. That's it. Which is something we did in pre-algebra. All right, just combining like terms. That's all we're doing. I'm sure everybody in here knows how to do this. All right, so somebody give it a shot. Come on, girls. Who's going to be brave? No brave girls. Yes, good for you.
4x to the third plus
4x to the third plus 5. Wow. Easy, I told you. Very, very easy. That's all you're doing is combining like terms. All right, let's go to number 12. All right, now what's the problem with number 12? We are what? But do I really need these parentheses here? No, I don't really need those parentheses. Do I need the second set of parentheses? The answer is definitely yes. All right, because the minus, I want everybody to make sure they remember this, even though I know you know. This is like a negative what?
1.
So you're really distributing a what? Negative 1. All right, you're distributing a negative 1. All right, when I distribute the negative 1, normally what I make kids do is this. All right, I change this to a plus, and then I just change the signs. So this g squared becomes what? Negative g squared, and this positive becomes a what? A negative. Now, because you're doing it on paper, instead of doing that, here's what I would want you to do. All right? Because you're writing it on paper, I'm not really expecting you to write the original problem. I would want you to do this, guys. I would want you to write the original g cubed minus 2g squared plus 5g plus 6. Now, in my opinion, here's the easiest way to do it. When I distribute the negative, I get what? Negative g squared, right? Now watch where I put the negative g squared. Everybody see that? And then the 2g becomes what? Negative 2g, and watch where I put that. Everybody see that? And the reason why I stack them on top of each other is just because it's easier for me to add or subtract them. All right? So when I do that, I don't get confused about what I can add with what. You can only add to g cubed, g cubes. Squares, you can only add squares. All right? So now, this g cubed, there's nothing to add to that. So that's just g cubed. And then after g cubed, it would be what?
minus 3g to the
Right, minus 3g squared. And then what? Plus 3g. Very good. And then finally what?
6.
Plus 6. All right, does anybody have any questions with that? That's question number 12. All right, so the only thing that's difficult is distributing a negative. The only thing that's difficult is making sure that you distribute the negative. Yes?
Why wouldn't you add g3 to 3g to this second power?
Because they're not the same. It's like adding 1 pencil plus 2 pens. You don't have 3 pencil pens, right? You just still have 1 pencil and 2 pens, or whatever I said. You understand what I'm saying? In order to add things, terms have to be exactly the same. All right? It's like adding x and y. Is it possible to add x and y? It's not possible to add x and y. All right?
When you do like negative 2g squared and negative g squared, you don't do anything to this one.
Exactly right. When you add 1 pencil and 2 pencils, you get 3 pencils, not 3 pencils squared. All right? That's how you remember those things. All right, so everybody take a look at 13. All right? So when I'm doing 13, please watch up on the board. When you're doing 13, I want you to write it in standard form. So I want you to write 2a squared minus 2a plus 4. Everybody see that? Write it in standard form. That'll help out a bunch. Then I'm distributing a negative plus negative plus negative. So now I have negative 3a squared, positive 8a, and a negative 7. Everybody agree with that? So now, simplify. Dalton, you all right?
Yeah.
Simplify that for me.
Oh, okay. 1a
What type of 1?
negative 1
Negative.
Yeah.
Good.
a squared negative 6a
Negative.
plus
Positive.
negative 6a and then negative 3.
Exactly. Is everybody with me on this? That's not that hard. Everybody agree? All right, let's look at 14. Now 14 is easier because it's just what? It's just addition, right? So let's combine. Now here's where you're just going to do mental math. All right, come on, everybody look at 14. Somebody tell me what the answer is. Tell me.
11y minus 13y.
Yes. However, I would prefer that you write negative 13y squared plus 11y. If you write it the other way, I'm not going to mark it wrong, but we just write things in standard form. All right, you try to write the answers in standard form. Everybody okay with that on number 14? Now remember, now's the time where you're trying to see if you understand what we're doing. All right, so now let's take a look at 15. All right, here we go. All right, here we go for 15. Now again, my recommendation is make sure you distribute the negative properly. Make sure you distribute the negative properly. All right, so the first one doesn't really change. So here we can just rewrite it like this. There's no reason for the parentheses. Is everybody okay with that? Now when I distribute the negative, the z cubed becomes what? Yes, thank you. Negative 4z cubed. Then what? Come on, guys. Come on. We got to wake up.
Minus 3z squared.
Minus 3z squared. Now, what's the problem with the minus 3z squared? There's no room for it. You agree? So if there's no room for it, all I do is I just take this and I just scoot it over a little bit and I try to write it in as negative 3z squared. Now, the last one is what? Plus 5. And the plus 5 would go under the what?
8.
Under the 8. Plus 5. Now, what I'm going to say now is, these, do you combine those? No, they don't go together because they don't have the same exponent. So now we end up with what? Tell us.
Negative 8z cubed minus 3z squared minus 2z plus 13.
Look how simple that is, guys. Anybody have any questions right now? All right, let's check out 16. Now, why do I like 16? Yeah, we're just adding. Do you agree? What? All right. So here, this is just a mental math problem. All right, Emily, why don't you tell me this one? Which ones am I going to combine? With what?
No, sorry, 2.
Look up. One more time. Let me erase this real quick. The square terms you combine with the square terms, kiddo. You see the little highlighted? Those are both the squares. Do you agree? So now it's negative 3d squared plus 1d squared. All right. Negative 2d squared. You agree? Now we're going to combine That's correct. But you have to tell me what type of 6D. And the reason why you're correct, but I still want you to say plus 6D, right? Because when you combine the terms, you're going to have to tell me if it's plus or negative. And then the final part of the puzzle here. Exactly correct. Now that makes sense now, right? Combining terms. That's all we're doing. Combining terms. Anybody have any issues with 16? All right, let's take a look at 17. All right, 17 is an easy one too because it is addition. Okay, Leah, you're up. Tell me about 17. Perfect. Perfect. All right, that is correct technically, but we want to put it in standard form. So if you put it in standard form, what will we do? What will go first? Yes. Keep going. Yeah, that's all. All right, that's all. Minor technicality. We write things in descending order. Everybody okay with that? All right, let's check out one more before I let you go. All right, now, again, combining like terms. All right, now when we write this, again, here's how I would like you to write it on your paper. 3n cubed plus n squared minus 5n. Then what? Plus, right? Notice, plus 8n squared. And then what? Minus 3n to the third. Very good. Minus 3n to the third. Now's the time where you're speaking up if you're not sure about something. Everybody okay with that? Everybody agree it's kind of easy. All right? Now, what happens to the cubes? They definitely cancel. So there's nothing there anymore. So your final answer is just what?
9.
Wait a minute. How much?
No.
9.
Squared minus 5.
Yeah, guys. That's pretty easy. Anybody have any questions with that? All right. Now what I want to do is we're just going to flip down to I think the problems are 1 through 18 and 20 through 43. Yeah. So now it's just those problems. All right, I think you guys are good. I think you know how to do that. Anybody have any issues? That'll give me some time maybe to call you to my desk and we can talk about your grade. All right, you can see what you're doing. All right, so everybody get busy, please. And what time do we get out of here? I already forget.
9:05.
Yeah, so listen, you still got, what, good 15 minutes to try to get this done. All right, chop, chop.